I gotta behave today.
Why do you have to record your
Since Josh isn't here, so I'm just gonna
Josh.
record the whole thing. Well, not just Josh. I mean, there's more people that aren't here, but I'm gonna record it today since they aren't here. He did email me to tell me he wasn't gonna be here, so that worked out. All right. So extreme value theorem, okay, is talking about basically that, our extreme values of a graph. Okay, so the first several that we do are going to be based on a graph, and then we're going to jump into what do we do if we don't have a graph. Everybody has one? We good? Okay. All right. Relative extrema. So these are the points on the graph. Of a function where it changes from what? Relative extrema is where the function changes from increasing to decreasing or vice versa. All right, so those are our relative extremes. So we always say relative min, relative max, and we go from there. Okay? And now, absolute extreme is going to be a little different today than what you've been taught your whole mathematical career. Not much different, but there is one added point to it today that we'll talk about. So your absolute extrema are the highest and lowest points. On the graph of a function. Okay, and I'm going to go ahead and add this little tidbit in here. I'll talk about it whenever we get down here, but an absolute extrema can be your relative extrema. So it can be a min or a max, or it could be an endpoint. Okay, so it can be a relative extrema or it can be an endpoint. And if it's an endpoint, the problem with that is at that endpoint, do we necessarily change from increasing to decreasing? If it's the end of the graph, like on a closed interval, does it change? No, but it could still be a max or a min. Does everybody understand that? But it's not changing because the graph doesn't continue past that point. Does that make sense? All right, so example number 1. The graphs of f and g are below. Use those to answer the following questions. All right, so A just asked us to identify the coordinates of the relative extrema of f. The relative extrema of f. All right, so let's look first at our minimums. Where do we think we have relative minimums on f? So anywhere where it changes from increasing to decreasing or decreasing to increasing. For mins and maxes. So what about our mins? What do we think? All right, right here. That's where we changed from decreasing to increasing, right? So that's a min. And then over here as well, correct? Both of those. Okay, so our relative mins are going to be, and we're going to give both, these are kind of our short answers, relative min at, and we're going to give the entire ordinate because it says the coordinates. So we're going to give both of them. So -3, 0, and 2, -6. All right, what about max? -1, 3. Easy enough? We've been doing that for quite a while. All right, letter B. Identify the coordinates of the relative extrema of G. Okay, so remember we're still going increasing, decreasing, or decreasing, increasing. So let's look at our mins first. So it's like we got one here, right? Decreasing, increasing, and then Up here as well. So let's see, that's what? -1, 2, -3, -4. And 3, 2. All right, what about max? -1, 3. All right, on the domain of F, what are the coordinates of the absolute extrema of F? Well, what can you say about the graph on the two ends of F? What do we notice? On both ends of F. They're both still going up, right? So do we have an absolute max of that graph? No, there is no absolute max. So see, these are going to keep going because those arrows, right? So we're going to have no absolute max. All right, what about our absolute min? Do we have a minimum value that is the most minimum it can get? Which one? 2, -6. All right, and then on G over here, what are the coordinates of the absolute extrema? So what is our max here? Okay, so remember, absolute max means it's the highest it can be. So which one's that going to be? Ah, there we go. This one over here, all the way up here. That's as high as we can get right there. Okay, so that's going to be an absolute max at 6.5. Okay, and then our absolute min. -3, -4. Okay, so notice we did not include 6.5 in our relative extremas. Everybody understand that? Because it cannot go from increasing to decreasing or decreasing to increasing here because it stops. Okay, but it is the highest point of the graph. Does everybody follow there? Okay, all right, so on the domain of the given functions, did the absolute extrema occur at the function's relative extrema? All right, well, let's look. Our absolute extrema here, our min. Okay, well, it worked here, right? Our absolute min was our relative min. Okay, but over here, our absolute max was not one of our relative extrema. Okay, so can we say that's going to happen every time? No, not always. It could happen. But it doesn't have to happen. Okay, because endpoints cannot be relative extrema. All right, now, when we go, so y'all's is on the same page, so doing example 2 will be easy because you're still using the same graphs that we used in example 1, okay? All right, mine are on 2 different pages, so it's going to be a little different for me. It's okay. All right, so use the figures from example 1 to answer the following questions. On the interval -2, 3, and both of those are inclusive, what are the absolute extrema of f? Okay, so this time we're not talking about everything. We're not talking about the whole graph. We're only talking about the parts that are from -2 to 3. So let me get mine. Hold on. Where did it just go? There it is. Okay. So I'm going to try to put mine above there so we can look at it. All right. So on the interval -2 to 3. Okay, so -2. So -2 is here. 1, 2, 3 is here. Okay, so that's the interval I'm looking at from -2 to 3. What are the absolute extrema of f? So absolute extrema of f on the -2 to 3. All right, there's an absolute max at -1, 3. Is everybody good with that? So between here and here, okay? Our absolute max is at -1, 3. And there is an absolute min at 2, -6. Okay, so again, if you were to cut off the rest of that graph, right, it's just saying what is the most extreme high and low point of that graph, just between those two intervals. All right, -4 to 4 on G. So -4 to 4 on G. So let's look over here at G. So 1, 2, 3, 1, 2, 3. So -4, 1, 2, 3 to 4. So we're looking here to here. From -4 to 4 on G. I'll give you a second to look. So we want an absolute min and an absolute max if we have them. Okay. All right, so she said a max at -1, 3. -3, -4 for men. Is everybody good on those two? So here, -3, -4. So we're in between our, so there's her min. Is everybody good there? Okay, and then she said the max was this one, -1, 3. Well, let me ask you a question. What about that one right there? Is it in line with the other max? It is. Is it at this point, is it an endpoint for us? It is, so it can be absolute. So that is a second absolute max at 4, 3. Okay, and understand that only happened because it was in line with the other max. Is everybody with me? So they both are going to be the answer. Had it been higher, it would have been the only answer. Had it been lower, the first one would have been the only answer. Okay, but just because they were in line with one another, so they are on a level plane, they are both absolute maxes there. All right, letter C. -4, 1 is our interval. So let's see, -4. So 1, 2, 3, so that's here to here. -4, 1. And we're looking for absolute min and absolute max. Okay, so I'm just going to draw real quick. So if we're here, right? It's like this part of the graph is what I'm talking about. Does everybody see that? From -4 to 1. All right, so what is our absolute min? 1, -3. Oh, it even goes further, doesn't it? It actually goes up to there. And our absolute max would be -4, 4. I didn't go far enough on my drawing, sorry. All right. And then the last one says on the interval -2 to 6. So -2 is here. And 6 is here. So from -2 to 6. Max would be 6.5, yes, sir. Min would be -2, yes. Okay, so that time it was both of our endpoints. So right here and here. So negative 2, 0 was our min, and 6, 5 was our max. We all good so far? Just reading a graph. Tell me what it says. All right. Okay, when the domain is restricted to a particular closed interval, at what 3 places could the absolute extrema exist? All right, well, we just said it could be the endpoints of the interval. Okay, we already know it could have been where f prime of x equals 0. That's what we consider our relative extrema, right? That's from past. Okay, so that's just our 3 reasons where f prime of x is undefined as well. All right, so everything that we do moving forward, like especially with example 3, it all goes back to everything that we have done, all of our reasoning for example 3. Okay, when we get into the second part of example 3 where it says continued, then we'll start using the graph that they give us. Okay, all right, so the extreme value theorem, or EVT as we're going to call it, states this right here, and it is nothing new that y'all already didn't know. We're just going to give it a fancy name. If f of x, I'll write it all out and then I'll read it. All right, if f of x is continuous on the closed interval AB, then f of x has at least one absolute max and at least one absolute min on the closed interval. Okay, what do you think are the 2 key points of that definition? Continuous is the first one. It has to be continuous. Okay, it has to be continuous. Continuity is easy to see on a graph, right? Not necessarily easy to see on an equation, but we know what to look for to find continuity on an equation, okay? What else? Closed interval, yes, because we have to have defined. Otherwise, if they go to infinity or whatnot, we can't evaluate that, okay? So closed interval is guaranteed to have an absolute min and an absolute max because we can count our endpoints. What's up? My initial answer is going to be waiting. I have one.
Okay.
But because none of our functions end up being just a straight line.
Would it be like, since like earlier, when like the 2 maxes were in line with each other, so they were both absolute maxes, would just every point on that graph be absolute max and absolute min? Like every single.
Yes, but then obviously you're dealing with an infinite amount of points.
Yeah.
You know what I'm saying? So clearly we would not
So we just
write
want
that,
to
right?
follow.
And there used to be a time, like in Math 1, a long time ago, where they would say if there was more than 1, then there wasn't an absolute. Like, because they would say absolute was only defined by 1. But that's actually a false statement. There can be more than 1 if they aren't any higher or any lower than each other. But yeah, in that situation of a straight line, we would not define every single one of them.
Just kidding.
Right. We would hope they gave us one like that and be like, infinite everywhere, but we're not going to have straight lines. So. All right. Consider the cubic function, negative x cubed minus 6x squared minus 9x plus 2 to answer the following questions. Okay, so let's determine the intervals where f is increasing and decreasing. What are we going to do? We're going to find the derivative. All right, pretty simple derivative. What is it? Negative 3x squared minus 12x minus 9. And then we want that equal to 0. All right, what can we factor out? We can factor out a negative 3. So if I factor out a negative 3, I'm left with x squared plus 4x plus 3. And then y'all are super duper fat. It froze. Did you say that? That's bad. Okay, well, at least my computer's still working. Hold on. TV timeout. Give me a second. You good so far? All right, we're great factorers, right? Hopefully it keeps up with us this time. All right, we're great factorers, so we're going to factor out, and we're going to end up with, what are our two terms? X plus 3, x plus 1. So what are our zeros? Negative 3 and negative 1. So that's what we're going to put on our sign analysis. Perfect. Okay, so if I plug in, now remember, I didn't get rid of that negative 3 because that's going to change my sign analysis. Okay, so if I plug in a really, really big negative number, right, that's going to be negative, that's going to be negative, times a negative is going to make that negative, and there's one dot on each one of these, so odd dots change, which means that f of x was like such. So we can say now that f of x is decreasing where? Negative infinity to negative 3 union negative 1 to infinity, because f prime of x is less than 0. And then we can say that f of x is increasing on negative 3 to negative 1 because f prime of x is greater than 0. Okay, so that's old hat, as they used to say. All right, and can you determine the x coordinates of the relative extreme of f? You can. What are they? We have a relative max at x equals negative 1, because why? Okay, so don't forget, there are two reasons why that happens. It is because f prime changes from positive to negative, and also f prime of negative 1 equals 0. So positive, negative, and it equals 0, okay? All right, so put that down, relative, and y'all can go in any order you want to. I'm going to do my max first. So we have a relative max at x equals negative 1 because f prime of x changes from positive to negative, and f prime of negative 1 does equal 0. Because those were our zeros. All right, and then in addition, we have a relative min at the other one. I don't think so. I just get in the habit of writing. A lot of times whenever I do look at notations, it does just say f is decreasing or f prime, because f prime is less than 0. It's just a habit of mine to put the x there, sorry. You can't go wrong by putting the x there. So, but they do count it if you say f prime or f. Okay. All right, we good so far? All right, example 3 continued. All right, so continue to use the cubic function that was given on the previous page, okay, to answer the questions. Identify the absolute max of f on the, so we're looking at the graph now over here, okay, so they have graphed the cubic function from the previous page over here onto this graph. So we're looking at the closed interval from -4 to 1, -1, sorry, -4 to -1. All right, so identify the absolute max of f on the closed interval from -4 to -1. So 1, 2, 3. So -4 is here to -1 is here. All right, absolute max from -4 to -1. What's it going to be? Let's see. -4, 6, and? Correct, they are both, yes. -4, 6. And -1, 6. They both work. -4, 6 is here. And then likewise, that one up there is also in that same interval. All right, what's the absolute min from -4 to -1? -3, 2. Right there. All right, so now for the next two, for E and F, we're just making that interval a little bit larger. So now we're going to go from -4 to +1, which is now our entire graph. So from -4 to +1 is the entire graph that you see. So what do you know about our absolute maximums? They say the same, okay? It's still -4, 6 and -1, 6. But our absolute min now becomes 1, -14. All the way down here. We good? All right, so now what they want us to do is they want us to give those same values without the graph. Okay, so how can we calculate that? That's what they're asking. They're saying, hey, if I gave you the same exact question, but I don't give you the graph, how can you do that for me? All right, well, we're going to use the extreme value theorem to locate the absolute extreme of the function on our closed intervals, and then we're going to use our algebraic results to concur with our graphical conclusion from the previous example. So when we're done, our answers to these should be the same as what we had up here. Is everybody with me? Okay, so we're kind of lucky because we kind of have the right answers that we should ultimately get to, and we're going to figure out how to get to them from here. All right, so whenever they give you the, when we want to find the extrema, right, we're going to use the derivative, correct? And we already found the derivative. What was our derivative? -3x squared minus 12x minus 9. Okay, and we already found our extrema there. What were they? -3 and -1, right? Okay, so we know something happens at -3, -1. Something, because those are our zeros of our derivative, correct? Okay, so then what we need to figure out is how about the ends of that graph? What happens on the ends of that graph? So what you do is you take your closed interval and you calculate your closed interval values as well. So we're going to do f. Now that's the beginning. F of -4. F of -1. That's our interval. Is everybody with me? Okay, from the original function, f of -4, f of -1. So we're calculating the value at each end of the original function. Okay, and then we're going to calculate the values of our extrema that we found here. Okay, I don't need to do -1 twice. It's going to be the same whether I plug it in here or down here. Okay, so I do need to do f of -3. All right, now I'm going to write the first one out, and then I'm going to know that y'all know how to use a calculator to calculate these for me, okay? So all we're doing is simply plugging in. So we're plugging -4 in here. So -4 cubed minus 6 times -4 squared minus 9 times -4 plus 2. Okay, so that's what we're doing for all of these. Okay, so when I did that for this one, I ended up with my value being 6. All right, then if you wanted to do them for yourself, you can literally go back to that same exact function and just override the 4 with a 1. Just repeat the function by hitting enter. Type all the ones in. Okay, so for -1, we also got 6, and then for -3, we're going to get 2. All right, so which two would be our maxes? -4 and -1, right? So we have absolute max at -4, 6, and -1, 6, and then we had an absolute min at -3, 2.
How do you tell which word pairs or which extreme is?
Okay, so your high value is going to be your high y value is going to be your max,
Okay.
and your low y value will be your min. So to tell whether it's a max or min, we look at the y only. And the answer will be both. All right, so let's do the same thing over here for B. So we've done, let's see, we've already done f of -4, right? We found that to be 6, correct? We did that in the previous problem. So we've got to do f of 1. And then we already know f of -3. And we already know f. So f of 1 is the only new value we've got to find, right? So that's -1 minus 6 is going to be -7 minus 9 is going to be -16 plus 2 is -14. Okay, so now what is our absolute max? What's the highest values of these four? The two sixes, so still -4, 6 and -1, 6. Everybody with me? And now what's your absolute min? 1, -14. So see, when we changed our interval, our min changed.
Are we able to use the union symbol for
The what?
We only use the union when it's an interval, right?
Right, yes, yeah, because we're actually given the x and the y value here. Now, in a minute, they ask for, well, in a minute, they only ask for the y value. But yeah. But yeah, we're not talking about the interval. I didn't know what symbol you said. I was like, the what symbol? I didn't hear that.
You only use the union if you're talking about it.
All x's are all y, yes, intervals. Because it's a range of values. So like, we're not saying the range from -4 to 6. We're saying the point -4, 6. All right? Okay, so for example number 5, for each of the following functions, state specifically why the EVT is or is not applicable on the interval -5 to 0 inclusive. Okay? So what is the main thing about the EVT that we said? What was the first thing we said it had to be? Continuous. So that's what we're looking for. We're looking for, is there somewhere that these three functions would be discontinuous or not continuous? Okay? So what about the first one? Is there somewhere that that is discontinuous? Where? It is at -3. Okay? Now, does that mean that this one cannot be evaluated? It's not applicable. Okay? Does -3 lie between -5 and 0? Yes. So because it does, then that means it's not applicable. Let's say that our closed interval was from 0 to 10. Is -3 between 0 and 10? No. So is that function continuous from 0 to 10? Yes, therefore EVT would apply. Does that make sense? Okay, it only doesn't apply because -3 is in our closed interval. All right, so EVT is not applicable I promise I hate having to spell these big words. I feel like I mess them up every time. Is discontinuous at x equals -3 which is in -5, 2. Or you could say at x equals -3, and you could use this symbol like another way you could say that at this point, just so you know, if you use at x equals -3, you could use this right here, which means which is an element of that. That little, it's like a C with a line out of it. Yes, sir.
Is there any synonym we could use for applicable?
I mean, you could say EVT does not apply instead of applicable. I hate saying the word applicable. There's a reason I teach math, and it's because English is not my forte. Especially spelling. God bless it. I say I before E except after C a million times in my life. I'm like, I before E except after C. All right, what about letter B? Is there anywhere that would make this discontinuous? Okay, we can't have a negative under the radical. Okay, so we know that x has to be bigger than, or bigger than what? It has to be bigger than 3, right? 3 would work, right? 3 minus 3 is 0. We can have a 0. But if we go less than 3, like 2, we're going to have a negative number. So we know x has to be greater than or equal to 3, correct? Okay, and if you weren't sure of that, you could have plugged in a number, like you could, because 3 was right here, right? That's what makes it 0. So we know to the left is going to be negative, to the right is going to be positive. You could have plugged that into C. All right, so let's see, -5. So what would our answer here be? Yes or no? What you think? No. So EVT is not applicable. Here's that word again, just for you. Because g of x is only continuous for x is greater than or equal to 3. Which is not, I should have written it, it's okay.
Can you like draw, if you did the element symbol, can you draw on through? Like how you write is not equal?
Oh, like a slash, yeah, which is not an element of, yeah. So you could say like, that. All right. What are our stipulations on natural logs? What can they not be? You can't take the natural log of a negative number. Okay, you can't take the natural log of a negative number. So we know that basically, we know that x plus 7 has to be greater than or equal to 0, right? So therefore, x has to be greater than or equal to -7, correct? Is everybody with me? That's a 7. X plus 7 has to be greater than or equal, so x has to be greater than or equal to -7. I'll write it clearer over there. I see Caden back there squinting her eyes to see my writing. Okay, well, the numbers that are greater than or equal to -7, are those included in our closed interval? Yeah, -5 to 0, that's greater than -7 is already between -5 and 0. So EVT is applicable because f of x is continuous and I'll use the element thing there just for y'all. Can't
Is it
even.
just greater than?
Yeah, yeah, 0 actually gives you a error as well, so it's just greater than 7.
Ms. Johnson, so for number A, like, we found that x is equal to -3, and that's in the interval, so would that be applicable?
No, because it'll be discontinuous there. That would make it discontinuous there.
Okay.
Yeah. Because see, like on B, like when we found that, so we know our numbers have to be larger than 3, right? So if we did -7 or anything like that, or I'm sorry, we'll say -2. -2 would make this discontinuous, and -2 is in our interval.
Okay.
So we had, this one was only continuous when it was bigger than 3, and that's not in our interval. We good? All right, last page. Yay! Everybody likes to see the last page. All right, let's look at the first one. Okay, so given the functions below, determine the absolute extreme of the function on the given interval, provide the extreme value theorem is applicable. If it is not, state why it is not applicable. All right, so, all right, is there anywhere at all that this function from the beginning would be discontinuous? No. It's polynomial. Polynomials are continuous everywhere, so we're good to go. We can keep going. All right, so then what do we need to find next? The derivative. Okay, we're going to use that derivative to find our zeros. Yes, okay. All right, so I'm going to give, what's that? 3x squared minus 4x minus 3. Okay. We could try to factor this, okay. It's not factorable, like by pretty numbers, okay. So we would use our calculator. Okay, or I didn't do the, I did the quadratic formula is what I did. So I'm going to draw that out on my notes. You can use the calculator if you want. I'm going to use the quadratic formula. I'm just going to draw that out. We should get the same answers, but now you can double check. So somebody find them on your calculator and tell me what you get, and I'm going to do it this way. So x is going to equal 4 plus or minus the square root of -4 squared is 16 minus 4ac all over 2a. So I ended up with 4 plus or minus the square root of 52 over 6. All right, which gave me so somebody tell me if you got either one of those values when you found your zeros. Is that what we got? Okay, cool deal. This would obviously be calculator active because they would not expect you to plug these numbers in. All right. So now we're going to find, so we've got our two interval points and we've got our two zeros. So we're going to find the value of those. So we've got to do f of -1, f of 3, f of 1.8685, and f of -0.5352. And remember, you can always do that. Hold on, I'll show it. 0.5352. Okay. I did it on my main screen, so I went and put that equation into my y1, the x cubed, and then, since y'all taught me that you can do this. So I'm not a calculator guru. All right, so I got -2, -2, -8.0646, and -1.1206. Everybody with me? All right, so what can we conclude now? Okay, so here's what, and I should have mentioned this earlier, sorry. So when it says in the directions, it says determine the absolute extreme values. When it asks for the absolute extreme value, it wants your y value. So this is where we would use the actual height that makes it the max or the min. So what is our absolute min value? Okay, and I will put min value at y equals -8.0646. And then we've got an absolute max value at y equals -1.1206. No, okay, because it asks for the extreme values, the absolute extreme values. So your extreme values are going to be, when you talk about min or max, it's your height. So what makes it a max or a min? And that's the y value. Okay? All right, so letter B is going to be our most, intricate problem of these. C and D are not super difficult at all. All right, so sine squared x plus cosine squared x from pi on 2 to 2 pi. Is there anywhere that is discontinuous? What does our sine graph look like? It's just a wave, right? And cosine is the same thing. Is there anywhere that's discontinuous from 0 to 2 pi or pi on 2 to 2 pi? No, that's continuous everywhere. All right, so we've got to do our derivative, which we're going to need the power rule and the chain rule. So what we got? Power rule 2 sine x. Derivative of sine is cosine. And then derivative of cosine is negative sine, right? And we want to know what, okay, so again, you could factor that. I actually did factor that until I was told not to. All right, you could factor that. So if you factor it, you're going to factor out a sine x, right? So you would have sine x, and that's 2 cosine x minus 1, right? And then you would just set each one of those equal to 0. So you want to know where is the sine x equal to 0 and where is basically the cosine x equal to 1/2, right? And that is on the interval from pi on 2 to 2 pi. Or you could graph it. And then the only thing is here, if I'm doing that, I'm going to change my interval to pi on 2 and 2 pi. And then I only care about, let's go 2 to -2. Just kidding. That should be a -2, and that should be a 2. So now I can see it a little bit clearer. All right, so how many zeros does it appear that we have here? It looks like 3, right? We've got this one, and then this one over here. But what's this one over here also going to act as? Our endpoint. So we don't need to find that one if you're going to do it on here. Like if you're going to find the zeros here, you don't need to find that one because that's our endpoint, which we already know is 2 pi. Is everybody with me? Okay. All right, so then where is our sine 0? Pi in 2 pi, so, okay. And I'm going to give you the decimal values here, okay. And then where is our cosine 1/2? And then we'd have to, so let's see. We're doing the derivative here, right? Yeah. So if I do these, I'm gonna give you the decimal. So second trace 0, right? Yeah. So what do we have here? 3 point, oh, what is that? 3.1416. And then I'll just go ahead and give you the second one. X equals 5.2360. That's our decimals if you found those two. And then obviously over here we've got this one over here, which we said was 2 pi. I can give you that decimal, but it's going to be included. Okay. So then we're going to do g of pi on 2. We're going to do g of 2 pi. We're going to do g of 3.1416, and we're going to do g of 5.2360. Do we trust that y'all can find those values enough for me to just give them to you? Okay. So this is going to be 1. Okay, this one when it's going to give you 0.999 or negative, which is going to be approximately what? -1. And then this one's going to give you 1.25. All right, and then from there we can find our absolute max and absolute min. Well, absolute max is pretty easy. What was it? 1.25. And then our min would be -1. Because we're looking at y values only when you plug those numbers in.
So,
Mm-hmm.
that graph that we were looking at earlier, what did you put in for that?
What did I put in? I put in the derivative.
Got it.
And then I changed my window to my interval, pi on 2 and 2 pi. All right, we good? All right, C. All right, let's see. So we are going to square something and take the cube root. Well, when we square it, what's it going to become? Anything you square is going to be positive, right? And then when you take the cube root, it's going to be a positive. So anywhere this is going to be discontinuous. Is what I'm saying. Like because this is ultimately saying, okay, that this is x plus 2 squared, the cube root of x plus 2 squared. So what I'm saying is when we square it, it's going to be positive no matter what. And then we're going to take the cube root, it's going to be positive, so we're good. Okay, so there's nowhere that's continuous or discontinuous. So we need to find the derivative. So bring that 2/3 down. And it'll be times 1. And then we'll clean that up. So that's going to be 2 over 3 cube root of x plus 2. All right, so how do we get our numbers here? How do we get our extreme of numbers? What can it not equal? Okay, so is there anywhere the top will be 0? No, so don't have any zeros up there. Can't be 0 anywhere, okay? And then down here, it will be undefined at x equals -2. You all right there? I always feel like I need to ask you if you want some water. All right, we good? All right, so what are our 3 numbers that we're plugging in here? -3, 6, and -2. We good if I give you the values? You sure? Y'all want to calculate them yourselves? Don't all speak at once. Everybody jump. We'll calculate them ourselves. 1, 4, and 0. Okay, and remember, you're plugging those into the original. Just remember that. Make sure if you are doing those yourself, it's back into the original. All right, so what do we have here? Max value at y equals 4, and an absolute min value at y equals 0. Last one, just in the nick of time. All right, so all right, in order for this to work, right? This right here, as we talked about, can't be negative. It also can't equal 0. Okay, so if it can't equal 0, right? Solve that out. So x squared can't equal 4. So x can't equal what? Plus or minus 2. Is plus or minus 2 on our interval from -1 to 3? Yes. So can we use EVT here? No. All right, it is not applicable because j of x is undefined at x equals 2, which is an element of -1, 3, right? This makes it discontinuous on -1, 3. All right, so when we come into class on Wednesday, the first thing we'll do is test corrections. I'm probably only going to give you about 20 minutes on that, okay? So I'll finish those up tonight, tomorrow. I was almost done with them, but I didn't like those. So we'll do test corrections as soon as you come to class on Wednesday. Everybody good? Say bye to our people.